We have quite a treat for our fourth example here. I take the product rule and I actually extend it to the next level. When you look at this problem, you can clearly see that it has three components. There's 1, 2, 3 parts to it. And if we're going to do a derivative with this type of function, instead of just having u and v, we're actually going to have something like u, v, w, which means that when I do a derivative, I want to take the derivative of u and leave the v, w unchanged. Then I move to the second part, I have to do a derivative for v and leave u and w unchanged. And then finally, when I get to the w, I'll leave the u, the v unchanged, but take the derivative for w. So it's an extension of the product rule. As I take this derivative, I'm looking at that first term. It's just a power rule. 5 times z plus 8 to the fourth. The next two parts remain unchanged. Plus, now I go to the next part where I'm going to take the derivative of the middle portion. So first portion, u remains unchanged. Power rule here, 3 times z minus 11 raised to the second. And then the w remains unchanged. And then finally, the first two parts remain unchanged. I have to do the derivative of the third part. So it's going to be a power rule again, 7 times z plus 3 raised to the sixth. Now as I look at all these parts, these sum of products, I see a great deal of similarity. And so what I'm going to do is pull out everything that they have in common. As you look at this z plus 8, I have one that's raised to the fourth, one to the fifth, one to the fifth. So that allows me to pull out a z plus 8 raised to the fourth. When I look at the z minus 11, I have one to the third, one to the second, one to the third, so I could pull out a z minus 11 to the second. And in a similar way, I have this z plus 3 raised to the seventh, and the sixth. So that will allow me to pull out a z plus 3 raised to the sixth. Now before I go any further, I probably should mention something about our notation here. This notation is saying to take the derivative of your function with respect to z, because all of the terms were in terms of z, with respect to z. Now, once I pull out what they have in common, I go back up to this part here. I have to list what remains. So I have this 5, and that's what I'm going to see right here. I have a z minus 11 and a z plus 3 from this first line. And since I have that left, I write that right there. From the second line, I have the 3, the z plus 8, and the z plus 3. So I list those. And from the third line, I had the 7, and then I had the z plus 8 and the z minus 11. On my next line, what I can do is expand all these binomials here. And so I expand each binomial, and then I'm going to distribute the 5 across, the 3 across, the 7 across, and I'll be able to combine like terms since these are all going to be z squared, z's, and numbers. Z squared, z, and just a constant. Z squared, z, and a constant. As I expand those, I look to combine those like terms, and here I get my final answer. I say the derivative of y with respect to z. Here's my common denominator, and then I get these three terms in the bracket where I've combined all those like terms. It was 15z squared minus 28z minus 709. Again, if you need to look at any of this stuff, I have printed out solutions. So if you think I'm going too quick or you're having trouble following, print off the solutions and look at those as we go through these. That may help you out. This was example 4 for the product rule.